Hi, my name's Lex Pruitt. I am a math tutor. I'm also a math teacher. Oh, and what about you? What are you doing here? I mean, duh, obviously you're looking for a tutor, but I don't know if you're a student. I don't know if you're a parent, a guardian. I'm not sure exactly what you're looking for. A lot of good tutors out there. There's a bunch of good ones with Wyzant. There are a bunch of good ones out in the world. And I like to think I'm one of them. I'm a very positive person. I'm highly organized. So yeah, I got a script for this video. Uh, Currently, I teach. I'm a current teacher. I've been teaching the last 14 years, to be 15 years, teaching online math courses. And this year I'll be teaching Algebra 1, Pre-Calculus, and an AP Calculus course, same thing I taught last year and the year before. So what I'm hoping to do is add 5 to 10 hours a week of tutoring with Wyzant to my current schedule. Why do I want to do that? Uh, well, I'm hoping to build a business with Wyzant, a tutoring business. So one of these days when I retire, I can still get up in the morning, have something to do, be productive, and make a little bit of money. So that's what I'm after. What am I offering you? Well, several things. Uh, One is a patient and clear understanding of the math that you're working on. Uh, I offer some life experiences. One of the things that I'm also offering right now to Wyzant students is in place of a 1 hour session, I'm offering two 40-minute Zoom sessions. That's two 40-minute, add them together, that's 80 minutes for the price of 1 hour. So why am I doing that? Well, I've got some reasons. One, the video with Zoom is a little bit higher definition. I've got easier access to the whiteboard, which gives you easier access to it. And those two 40-minute sessions can be back to back. We can do a 40-minute session, hang up, take a break for 5 minutes, and then do the next 40-minute one. We can do 40 minutes today, 40 minutes next week. That can be set up a lot of different ways. And again, I'm restricting myself to 5 to 10 hours of tutoring a week because I do have a busy schedule during the day, and I want to be able to provide high quality tutoring services. And so I'm going to limit the number of hours that I do. One of my life experiences has to do with tutoring for Prodigy, which I did a few years ago, and I learned some things from that experience. One of the things I learned was more patience. I relearned how important it is not to assume anything. And the third thing that I learned was that I'm better working with upper grades of math through grade 7 through 12. I'm better at that than I am working elementary grade math students in grades 2 through 6. So I learned that about myself. I'm a visual learner. I like to draw pictures when I do math. So if you're an Algebra 1 student and you're working on, let's say, finding the intersection of two lines, well, I like to graph that and actually look at where they intersect, as well as work the algebra out to find that point of intersection. If you're a pre-calculus student and let's say you're working on a problem and you need to find the measure of an angle or those angles where the sine value of that angle or those angles is -1/2. Well, I like to draw a picture of the unit circle and explore it to find out where the sine value of an angle is -1/2 and associate it with the angle. So if you're looking around in quadrants 1 and 2, you're in the wrong place because sine isn't negative in those two quadrants. I was working on a calculus problem a few days ago, last week, and it had to do with pulling a boat in. There's a man, he's got a rope, the rope's attached to the bow of the boat. he's pulling the boat into the dock to dock it for the night. And the rope is so many feet long, and it is in his hands, and his hands are actually 12 feet above the bow of the boat. Okay, so the rope's coming down this way, but he's pulling the boat's going that way. So he's pulling the rope at a rate of 3 feet per second. Well, this is a related rates problem in calculus, and the question is, how fast is the boat moving? So I like to draw a picture, and let's just go draw a picture of that scenario. We're not going to work through the problem, but illustrate the kind of pictures I like to draw. And I'm a terrible artist. I tell you that right away. I flunked art in the 7th grade back when they would actually flunk you for your inability to draw the picture of a horse. So my art's not great. Anyway, here we go. Let's get our guy. Here's our guy. All right. Boom. We'll give him a couple arms and a couple legs. All right. And here's our boat. Our boat's out here. I don't know, we give it a little flag or something. And here's the rope. Here comes the rope. That's not really great, but it'll work. All right. So the distance from the man's hand straight down is 12 feet. This is 12 feet right here. The distance the boat is, so this is the boat. We'll draw a boat there, is X. We don't know how far it is from the dock, but the man's on the dock. So he must be on some kind of platform for his feet to be 12 feet above the boat. But that's the scenario that we're given. So that's what we draw. And this side of this right triangle, guess what? I mean, we draw this picture and all of a sudden we visualize that we have a right triangle. Wow, that's kind of nice. What is something you learned in Algebra 1 about right triangles? How about the Pythagorean theorem, a squared plus b squared equals c squared? How does that apply here? Well, as it turns out in calculus, and working on a related rate problem, at least at the high school level, there are 3 tools for solving related rate problems, and one of them is the Pythagorean theorem. All right. So in our picture here, we would have x squared plus 12 squared equals r squared. Well, we're given the length of the rope currently is 20 feet. And we're told that he's pulling the boat at a rate of 3 feet per second. Well, the boat, how fast is the boat moving? That's the question. All right. Well, the boat isn't going up this way along the rope. That's not the way the boat's moving. The boat is moving on the surface of the water. It's not moving at 3 feet per second. That's the rate the rope is moving. All right. So we write down our given information. We've got it in a picture. I love these little pictures. They help me a lot. And in calculus, what we're dealing with, what we're trying to find is how fast x is changing. Okay, this distance x is changing as the rope is being pulled at 3 feet per second. The distance x, the distance of the boat from the dock, is changing also. And that's at a rate, and in calculus, we write that as dx dt, the rate of change of x with relation to time. All right. We know the rate of change of r. So we're given dr dt, the rate of change of the length of the rope, is 3 feet per second. And we can take all that information, this given information, and what we're looking for, and the Pythagorean theorem, okay, take a derivative of both sides and then insert the given information, then solve for dx dt. Kind of what it boils down to. We're not going to work through it. It's just an illustration of how I like to draw pictures, because again, with me, it clears up a lot, helps a lot of what's going on. So, all right, there you go. We're going to stop this sharing of the whiteboard. And that's pretty much it. A quick introduction, who I am, what I do, what I can offer. If you find that acceptable and you want to work with me, I would love to work with you. So let's see what we can work out. Adios and nos vemos. That is Spanish for goodbye and see you later. Now I'm going to look down so I can end this session and stop this recording.